Hey there, I'm Alex Bros. I'm an aerospace engineering student at Georgia Tech. Today I'm going to be discussing and just demonstrating the phenomenon of precession, which is change in orientation of an object's axis of rotation. So to do this, I built this gyroscope here. As you can see, we have this outside frame. The inner frame can rotate pretty freely. And inside we have a test object, and I only have two hands here, but that test object can rotate freely in there with very little friction. So we got three objects here. Our mission today is going to be to find out which of these objects can rotate arbitrarily fast. So what that means is, can these things rotate in here faster than I can spin it about this axis or steer this frame right here? So that's going to be our mission today. Before we get started, let's just quickly go over some of the definitions of my axes here. So we have the y-axis here, so that's going to be this kind of rotation. We have the x-axis along here, so that's going to be the internal frame moving like this. And the z-axis is going to be the spin of our axle, and the precession that we're going to be looking at. Okay, so here's going to be how we actually test the objects. Each test, I'm going to hold the gyro up like this. We're going to apply an omega x this way. That's going to be a positive omega x direction. And then we're going to rotate this, give it some omega y. And then we're going to be looking for a precession of the object inside this axle. So that axle should rotate a little bit when we apply both an omega x and omega y of those two frames. Alright, we're going to go ahead and commence testing for our first object, which is going to be the square. Look how we have this black marker. We're going to line it up with the x-axis here and then see when I'm done spinning if it has moved it or not. So let's go ahead. And not really any movement there. Let's try again. Alright, this one is going to be our disc. The same thing, we got a little black arrow there lining it up here. And let's go ahead and see what we get. It should be similar to our square. Yeah, didn't really move much there. Not much there. We got a little bit there. You can see that. Alright, last but not least is our rod. There's the black arrow. It's going to be our x-axis right here. Let's go ahead and see what happens. Just had a little precession there. So we speed it up, we can see it really rotates a lot here. Even if we start the arrow out on this axis, look, it's all over the place. And it seems to follow the inputs pretty well here. Quite amazing, isn't it? Alright, well, the answer to our question why the rod is able to spin so much faster like this than our other two objects all lie in the math. Specifically, this term right here, Iy minus Ix. So both the square and disc, because of their symmetry on this, their Ix and their Iy are nearly the exact same. So that Iy minus Ix goes to 0. That's why we're not seeing anything. The rod, it's very unsymmetric here, as you can see. Very different. So its Ix is extremely small, and its Iy, however, is significantly larger. And That's why we're seeing such big differences. We just were able to answer the question to our experiment here, that the rod of these three objects, the rod is the one that can go arbitrarily fast. We saw that just by a small amount of rotation here, we can get a lot of precession. So thank you. This concludes our experiment.